Moving us on to our next presentation, so we've got Dorota, Charlotte, and Kristian from the Northwest Ambulance Service, talking about a really interesting project looking at using some of the geographic modelling methods that we taught on the programme to try and redraw ambulance dispatch boundaries. So lots of interest for this one, I suspect. Over to you.
Hi everyone, just let me know when you can see our screen. That looks like fabulous. Okay, yeah, so my name is Kristian. I'm a BI developer at MWAS. It's my partner Charlotte.
Hi Charlotte, yeah.
And Dorota is, so she won't be in today, but she was part of our project as well and helping get this all here today for you. So without further ado, we'll just run through what we've been up to. So in today's talk, we're just going to run through the background of our project, the primary aim and our objectives that came out of getting involved in this project, and our progress so far with our in-house data, the use of Python, thanks to HSMA calls, and how we've been utilising ArcGIS in particular towards the kind of inception of our project. So let's get those cogs going. And so yeah, I'm going to talk now a little bit about the background. So currently, MWAS uses dispatch boards, which are based on historic local authority bounded polygons, and these are what our operations teams use to dispatch our ambulances across the MWAS footprint. Now, the cross-boundary allocation of resources has been causing issues. So between different boards, you'll have an operations centre where you'll have several operational staff who may have to literally shout across the room to ask, oh, can I borrow an ambulance from your sector to come over into my sector? And quite often, as you can see in some of these cases, you've got these very higgledy-piggledy boundaries, which, as I mentioned, they're based on historic boundaries, so they wouldn't have taken account of things like motorways. So our example here is around Manchester, where you've got one sector that goes kind of up towards Bury, then comes back into Manchester, then out towards Salford. And quite often you'll get an ambulance that may need to cross that boundary, but it just creates a much more complex scenario for trying to get an ambulance to that incident. And what you also find across all these different sectors is quite an unequal distribution of resources and demand between those boards. So when it comes to going from day to night, for example, with shifts, you'll get a merging of some sectors, but it's not, even then, it's not quite an equal distribution of those resources. And again, you get peaks and troughs in demand that really could do with further improvement and development. So looking at the case of these resource distribution as well. So up in Cumbria, you have a gigantic footprint. So you can see with that shape area, we've got one sector right at the top that's 14 million, I believe it's comic on the square, but it's a huge area, and there's 63 bases that are all in part of that. So one dispatch board has to manage essentially 63 bases, whereas you go all the way down towards Sefton in Merseyside, so you've got places like Southport included in that, and there's only 5 bases, but it's still quite a busy area in terms of demand. And so that huge variance in sector size and geography creates quite a complex scenario there. And then, yeah, as you can see from this graph down here on the left-hand side, there's quite an unequal distribution of demand between those different sectors. And for operational managers, that's quite difficult to manage on a day-to-day basis. So that's our background. So in terms of our aim and objectives off the back of this issue that crops up for MWAS, what we want to do is devise an updated division of the MWAS service area into more weighted resource dispatch sectors that take into account, you know, where do people live in 2025, where is the incident demand in 2025. And I mean, ultimately our objectives are to reduce cross-sector ambulance allocation, to reduce ambulance response times in an ideal world, and in theory produce a repeatable methodology for producing set polygons based on annual demand data. So in theory, once we have a big block of code, we can just repeat that on an annual basis to keep it dynamic with patient needs. And in theory, you could just lift and shift that model to any other trust, any other local service or authority who may be here today who may want to use that methodology. So, yeah, as I mentioned, so what we want to do is we want to be able to report on the attributes within these polygons, but also we crucially want to be able to extract that those polygon boundaries for future development. So for any revision on an annual basis, or if we want to do any kind of little tweaks based on any kind of geographical feature or anything else that might crop up. So that's our aims and objectives. And Charlotte's now going to talk through our progress so far.
Thank you. So obviously, like we said, we wanted to make this a project that we can do in-house and review, however frequently feel we need it, depending on how things change. In terms of our data, we've looked at the last 3 financial years of data to look at those unique face-to-face incidents. We focus specifically on face-to-face because we have an absolute wealth of data. And we've also limited the resource type we've looked at to a standard ambulance double crewed because we feel like that will give us the coverage that we need, and we don't want to overcomplicate our model. So we started off extracting this from our warehouse in Python, and then we've had to, the way our data is recorded, we've got some things that are recorded in lat long, some things in northings and eastings, so we've had to do some conversions for that to get everything the same, and then also we wanted to look at it on a global map as opposed to a flat map, so we've had to do some adjustments to account for that as well. We've ended up using quite a few libraries. We've done a little screenshot on the right there that you can have a glance over, in terms of what we've needed to use. I think the main ones that we've used are sklearn, SciPy and OSMNX, which is an open source road network mapping visualization. It's been really useful for what we've been wanting to look at. And then possibly the most interesting discovery we've found, which has worked really well for this, is the Voronoi tessellations that we have utilised. So these Voronoi diagrams are a partition of a plane into regions close to each of a given set of objects. So there's a little colourful map there to kind of show you visually kind of what's happening. So each one has a seed and then a corresponding region, which is a Voronoi cell. And that's kind of how we focused on our data. So it's kind of looked at, right, where are these incidents, and then follow a pattern around that to then bring it into tessellations. So we've used k-means clustering for the seed, and then the Voronoi tessellation is the region, and then obviously then we wanted to visualize that on a diagram, so we've done all of that within Python. And we've kept a random state variable within our coding so that we can, see if we change that random state, what minor adjustments there are, because, even though we're following this in terms of where all the incidents are and where the demand is, there are nuances geographically, so by having slight changes as we iterate it through the different random states, some are better suited geographically than others, and this random state essentially dictates where the tessellation starts from, which is why we do get some variation. So overall they're quite similar, but depending on where it starts, there are differences, which we've zoomed in on a couple there just to show you the slight nuances over in that area. But it's been really useful because then we've been able to work very closely with the experts on these different areas that are working this with the dispatchers constantly, and they've been able to pick out which ones they know are really good and which ones aren't, and we've ended up picking out a random state that we think fits our geography for the Northwest the best by liaising with them. So in terms of how we've done that in Visual Studio Code, we've kept it just on a normal, we've not overcomplicated the visualization so that it's not slowing down it loading, because we could do this within Python on a real world map, but we found that it's actually really quite slow, and we've not found a software that's produced it fast enough for us, which is why we've then taken that, we've exported that out into a GeoJSON, and then we brought that into ArcGIS, which is then better suited to do this quite quickly then, to have that visualization. So we know roughly where everything is on this map geographically, because we're doing it day in, day out, but then to see the real nuances with the road network, etc., we've then exported that and brought it into ArcGIS to really then start delving into it. And so then this is what that looks like within ArcGIS. So on the right hand side, you can see the first graph is showing our current sectors and how that's split up. And then next to it then is our proposed sectors, which we will be tweaking very slightly, again, liaising with them, but we can do that within ArcGIS for what we found to be the best fit with these tessellations without doing any alterations. I think the key differences that we've done is we've based our incident locations on 20 sectors rather than 23. That's because, ideally they wanted to reduce it. We found that was bringing out the best shapes for what we were looking for as well. Some of those need refinement, for example, Southport, Blackpool, when it comes to like coastal areas. Sorry, I just realised we are running over. So I will quickly skip through, but yes, there's just a few amendments that we need to make. So in terms of next steps, we've zoomed in here, we need to do some manual tweaking. So you can see over here, it's cutting off this bit, which obviously isn't great. So we will be bringing this down to make sure that flows. And we're working with those operational teams in which to do that. And then I'll hand it back over, Chris, for a quick summary.
Yeah, it's a really quick summary. Yeah, literally a really positive reception. It's been a really great case-based use of the HSMA content. So thank you very much, HSMA team. And already getting loads of really useful insight. And yeah, as I said, really good potential for easy application to other external scenarios once we get GitHub up and running. So that is our lovely presentation. And thanks for listening, everyone. And any questions, feel free to post in the chat.
Thank you very much, both. Fantastic presentation, and again, really different. I don't think we've ever had anything like this actually in HSMA, so it's been fantastic to see you explore some of these really interesting, more advanced concepts, and really nice demonstration of kind of HSMA as a springboard to exploring other things. So yeah, fantastic. Can't wait to see how this gets implemented and used moving forward. Brilliant, thank you.